Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Zero, and welcome to Code Red. Code, because we are talking about code, and red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage.
My guest today is Luca Forni, co-founder and CEO of Akamas, which focuses on autonomous performance optimization. We will talk later what that exactly is. And before that, we have a very similar history. Luca also worked in consultancy and worked with the major brands in monitoring, APM, and observability, and did a lot of performance optimization projects. Luca, happy to have you here on my podcast.
So thank you, Mirko. Thank you for having me here on. And so it was great to be on this podcast. I really loved and enjoyed all the other episodes. So really excited to be here. Thank you.
Yeah, and as you know, if you listen to them, the first question is always, what was your biggest Code Red moment?
As you mentioned, dealing with the performance optimization and troubleshooting and so on as a consultant for more than 20 years right now. The worst one, I think, it was about dealing with mainframe, where a customer asked me, hey, we moved the mainframe another location to consolidate everything, and now everything got crazy at the end user side. So, but we can't understand why. So at the end, after not spending in troubleshooting and so on, it just turned out that moving the mainframe means added a little bit of latency for every single calls. So talking about microseconds, but because of the number of calls to the mainframe was something like 3 trillion per day, at the end the result was the front end completely crashed due to a lot of requests that was on the front end side queuing. And so, but it was very hard at that time because it's 15, 17 years ago. There was no APM tool that give you exactly the tracing from mainframe to the front end. So we need to do that manually, trying to correlate logs because Spark was not on the field at that time. So that's was the first, I think, the first moment where I say, we need to think about full stack. So having some time that is able really to have in the observability world, monitoring APM, something that really give you all the metrics from the mainframe, from the hardware to the final end user, the rendering phases of an application, because otherwise you can't really understand how system works. You spend a lot of time in dealing with this kind of issues.
I love that you are 20 years in this space and you talk about mainframes, because now I'm not feeling that old anymore, right?
Yeah.
I did a lot of projects where customers, especially in the banking and insurance sector, where the mainframe is still part of the backend or still the main backend, the database, SIX and IMS transactions, and you call them from a web front end or whatever, and you need to trace through it. There are not many solutions. By the way, when we sold Instana to IBM, that was one of the biggest projects that IBM added all the tracing for mainframes so that they can handle that traffic for their customers. I think it's an amazing tool today so that you can trace from the front end to the mainframe in one platform.
Not sure how the customer are evolving in the last 5 years in terms of requirements for observability, because we moved in different side area of observability. Maybe we talk about that. But yeah, definitely still I remember that customer wanted to have something that cover all the different technology, everything, because they need to have a clear picture and they need something that can correlate everything, because sometimes it's like the butterfly effect, something that happens in a specific part of the data center or the cloud or your system that maybe are distributed can impact the users in a different country, in a different location, and it's very hard to follow the path and the full stack. Sometimes it's a matter of having the full stack observability that mix up very old technology with the latest microservices, Kubernetes, and cloud native solutions. So yeah.
Absolutely, yeah. But you have even the harder job, right? We observe things and you say you optimize them, right? Which is next level in my point of view. I think we will talk about it, but I guess you get the data from observability tools somehow also. And when we had some email interaction, in one mail you said you're basically the next gen Turbonomics, right? I had Ben Nye on my call, and Turbonomics got also sold to IBM. So I guess it's time for a next gen player in this space. And I know how Turbo works, right? It was initially built especially for VMware and optimizing virtual machines. So it's a full stack thing, right? That you look at the lowest level infrastructure host level, and then you also get the metrics from the application, because you actually want to optimize the performance on the application and minimize optimize the hardware usage and the infrastructure usage.
Yeah, it's a matter of resource efficiency that at the end is improving performance while reducing cost. Even if I totally agree with what we were saying in a previous episode with Ben, I would say sometimes or almost all the time, performance is the key. Not really cost optimization, even if cost optimization for a matter of, go to market, the sales rep say, hey, guys, I can save you cost. It's easy, but, there are several ways to do this kind of job. If you can pitch that you can really optimize things that create improved efficiency while reducing cost, that's just one of the addendum of the full equation. But the real value is if you are able to observe all the data, create correlation between all the data you collect from at full stack level in all the pieces of the puzzle that is your stack, and sometimes are hundreds of pieces in this very complex puzzle, you can really understand how the system works and then optimize the things that need to be optimized in order to create the perfect balance between all the part of it. Is like an F1 car. I don't know if you never heard about Jackie Stewart. That was a F1 driver. That's I think I know it's a legend that he created this concept that's called the mechanical sympathy. So he was not the best driver. It was a very good driver, maybe not the best one, but he was very intimate with the engineers, with all the mechanical. So he know how to drive the cars because he know how the brake works, the shift works, the steering wheel works, the engine works. So he was able to adapt his way to drive the F1 cars in order to make all the parts of the cars work smoothly together in a balance. It was exactly when we invented Akamas, we tried to create something that is able to understand deeply how the system works in terms of all mechanical parts. And, a cloud-native application can be compared to an F1 cars that need to work perfectly in every single element. And sometimes are external, third-party elements. So you have not a clear control of that. And the result is that, okay, you can do that with your brain if you are an expert. So we need AI. And the spoiler is that it's not Gen AI because there's no way to train a model for that. So when we start Akamas in 2017, we start from scratch with a totally different approach for AI. We patented the AI. It was one of the part of we are so proud of because it's a total new approach for solve this kind of problem. And at the end, the problem is solved by improving performance, and as a side effect, reduce the cost because you improve efficiency. So the same system, the same hardware, the same unit of elaboration can give you more transaction, more throughput at the same cost. So at the end is matter of efficiency. So it's a cost reduction.
Yeah, makes sense. And can you explain a little bit how Akamas works? If I have an application with my stack, what do I have to install something, or do I have to have a observability tool that sends the data to you? And then what are you doing, right? Actually, how do you optimize autonomously?
So the idea is that because we were in this area since 20 years, myself and Stefano, my founder and CTO of Akamas, say we don't want to reinvent the wheel. So we don't want to address the observability market that is full of great technology. At the same time, we don't want to address the automation part because Akamas wanted to autonomously change things on your system. And so we say, okay, we need to rely on what the customer already have or suggest the customer. So we come from consultancy mindset. So we continuously try to suggest customer the best tool in the area. So at the end, we say to the customer, we requires an observability tool in place. If required, we have some partners that with professional services can help you in creating or suggesting you the best one for your needs or implementing the best way the observability tool for you. And the same for automation. And our AI act like the brain that observe data, grab data from observability tool. So first of all, no agent at all. Install it on your system. We can grab data directly from your environment, but 99% of customers already have something in place and don't want to give you the assets to your system. And then our AI elaborate the data, so analyze the data coming from the observability tool, understand how the system works. That's why it's very important to have a full stack observability tool, because the AI can work trying to get the mechanical sympathy. So try to create the balance between all the pieces of the puzzle are configured, and then we act. So via automation, don't want to change things in your system directly, but use what you have in place. So relying on your pipeline, relying on Ansible, Chef Puppet, whatever, Terraform, whatever you already have in place. Also in a matter of policy security is exactly what the customer do. Usually they do after someone, an expert, analyze the data and suggest things, and someone manually implemented in the pipeline. Now it's the AI that in a matter of snap, analyze the data, create live the model. So it's not a training model for the AI. Understand how things is wrong and apply that. And then get back the feedback from the observability tool, because a change in the system results in a change in the metrics of the observability tool. And the AI learn and continues work in this way. So it's autonomous because it's a cycle that never-ending cycle that continuously analyze data, calculate how to make changes in their system, and apply the change via automation, analyze the feedback, and so it's a reinforcement learning, of course. The important part of the story is that we do not change any code on the system. We only work on configuration. Why configuration? Because it's something that was never approached by any other tools. So usually there are a lot of tools that try to improve the code, especially now with Gen AI, improvement of the code can be done. But, if you think about standard application that runs on Java, JVM, Kubernetes, JVMs come in more than 600 parameters. Of course, not all of them related to performance at the end, but a part of them are related to performance. Kubernetes itself has a lot of different parameters you can set. Databases, cache system. You can have several runtimes, several microservices that runs into pods. Every one of them is their own, component. Sometimes are MongoDB, Redis cache, Spark itself. All of these kind of tools brings with them hundreds, sometimes dozens of parameters, but you need to tune them in a mechanical sympathy approach. So all of them need to. So the need is someone that is able to say, okay, because I changed something over there, I need to change something over there. Otherwise, I can result in the butterfly effect. So I change over there, create a mess over there. But if you have the AI brain that is able to balance everything, you can really have a system that is work perfectly, very smoothly, with the maximum efficiency. And the result is also something that give you a good, ASG flavor, because at the end also the carbon footprint is very low because you are at the maximum efficiency possible for your system. So that's the idea behind Akamas, and that's very simple idea.
That's very interesting. So as far as I understood, I'm trying to always understand what that means, right? So you take the data of an observability tool, all the data like metrics, logs, tracing, and then you probably have to build something like a graph of the dependencies of the components, right? If a JVM is running in a pod in Kubernetes on a few hosts, you have to understand that relationship, right? Because you kind of have to tune all the parameters of that JVM and the underlying infrastructure. And then you have to change the configuration and do some sort of A/B testing, right? for example, you optimize the garbage collector and then you will look at the metrics as they improve. That's how I see it, or is that totally different?
Yeah, generally speaking, that's the main concept where we started with. But at the end, creating like a chart or like graph with all the relationship in a like a CMDB way or Smartscape like the Dynatrace one, would be so heavy in terms of competition. So we force our research team to try to about that. And part of the patent that we got, we currently have 5 patents, is the fact that we create an AI that it's a total black box approach. So do not require to know this kind or to have this kind of a relationship written somewhere.
No.
But it's something that is discovered live. So the fact that the model is treated live include also in a very lightweight approach also all this kind of relationship. So of course what we understood and we tried that having this kind of a relationship since the beginning create a boost in how the AI get the best result, the best possible results. But our AI is also able to do that without having this kind of information. So one of the claim of Akamas that sometimes can be, for a customer, it can be very strange, is that we can address any technology, even if the AI never encountered this technology. Why? Because for Akamas, every technology is that, let me say, a matter of new parameters that need to be tackled. And then it's the AI that understands that these parameters that maybe come from the same technology, but are somewhere related in some way. So that's part of our mantra, to avoid to need to be strictly related to a CMDB or something like that. Of course, what we created, as soon as Akamas started being used at the customer side, that we can create what we call optimization pack. So you can create these kind of libraries that for every single technology, and something that we provide out of the box, but the customer can create, the community is creating and supporting us in this way, that for a specific technology, give you the full set of parameters. If there are any dependency of the parameters between each other, sometimes, if you set a specific garbage collection type, then you can set some sub-parameters that are related to the main choice you have done. So there are some simple YAML files that exactly created these rules, but are super, super lightweight. And the customers, ourselves, system integrator can create them. We ask to the community to collect them, so we bring them all together. And the idea is that improve the speed of the AI in order to get the results as fast as possible. But let's consider that we have some enterprises that, thanks to the Akamas, in literally hours, that means sometimes 20 hours, less than 1 day, we're able to save and reduce the cloud cost by 80%.
Wow.
So reduce cloud cost, that means improve the efficiency of the number of transactions on the same EC2 instance that require them or allow them to cut off 8 machines up to 10 to exactly serve the same workload. So it's getting back to performance. It's a matter of improve dramatically the performance that at the end you get a lot of money saved back because you are on a paper minute approach. So if you can turn off something, it's great. Otherwise, you can say, okay, we can serve more and more load on the same hardware, and you have free space for other load, other application, and so on. So it's not always a matter of improved performance.
And this is done totally autonomously, the optimization.
This is done autonomously. So you give Akamas your application, so the way your Akamas can interact with the parameters of the application, the observability tool. So we have now supported some tools, the most common, but also a CSV file, if you want. Because sometimes it's the best way to have everything in one unique space, like a NoSQL database or time series database or something like that. So we have a lot of customers that have their data lake where everything is put on, coming from different data sources. We grab data from them, they export us in some way. And Akamas continuously ask, get the results from this kind of metrics, analyze the data, change things, get the feedback, and so on. So, yeah.
And then the automation, do you do the scripts or are you reusing existing scripts of the customer? So if I have Puppet or Chef, you mentioned that, or Terraform.
We usually ask if you want to change like a new release. It's not a code release, it's a configuration release. So if you want to change parameters in your database, how usually you do that? I will have a PR or I set something there. I have my repo in an XML file in a database system, and there's a trick that as soon as a change occurred, trigger the new release, the pipeline. As soon there's some policy that allow you to start the release, a new release apply. So it's something that I can invoke via API. Yes. What I need to do, you have to change this property in the XML file, and that's it. So we tend to avoid to change the process, the current process, for a matter of security, for a matter of policy, and also for a matter of trust. Because, if you say to a customer, my AI is able to change things in your production system, and you're a bank, they are a bit scared. I can't trust them, of course. So if you say, okay, the process is exactly the same, which is the different, we have an AI that is like 1,000x expert than your most expert, because it's able to analyze tons of data in a matter of seconds instead of having big war rooms with all the people on a table discussing the impact of a specific change. It's something that the AI can learn very fast and then can also decide, in order to make a change, to create the best balance, especially for a matter of avoid to crash the system. So part of the patent is the safety, that is what we guarantee that our system won't crash your application. Sometimes can create a little bit of degradation because it's part of the training process that's happening live, but it's a way to let the AI learn that this kind of change in that direction, improve, or change a little bit of parameters, creating something that is, 1 millisecond slower, so it's not the best way to work with. So at the end, the AI immediately understand that, get back, and continuously learn in this way.
And how you deal with pricing this kind of service? Because I could imagine, like if you say, hey, you come in 20 hours, you optimize 80% of my infrastructure, and I say, oh, Luca, that was nice. Thank you. Now you have optimized my infrastructure. I don't need you anymore, right?
That's to be honest, that's a continuous fight with my sales rep, of course, because I personally invented the pricing model, and still I earn my sales rep that are complain with me because it's very hard to match the infrastructure you are changing with the fact that you are changing the infrastructure. So sometimes it's which is the real infrastructure, the first one, the second one that I was able to reduce. So we start from a very simple pricing model that is the number of concurrent optimization, and an optimization is this cycle applied to an application. Where application means what the customer consider an application. Why? Because of course you will say, oh, my full data center, my full set of the application are the one application, so I want to pay just one license. Okay, but you bring a lot of different elements with hundreds of parameters. Maybe the AI requires 2 months to start giving you interesting results. If you split your big application in microservices, set of pieces of the stack, you maybe get the results in some hours. So you pay more, in terms of license, because every single license is 1 year subscription license for every single concurrent optimization running. But at the end, you get the saving in a matter of hours. So the total result is great than having just one single license. You pay Akamas low, but you need to wait for 2 months to get the benefits for applying Akamas. Unfortunately, sometimes happens that the customer just in having one license can save millions, happened in a matter of days. So the results was, it was a very large big data system where Akamas changed Kubernetes Spark some runtimes, and in a matter of hours, literally a matter of hours, was able to reduce 1/3 the total cost of the application that was 3 million per year. So at the end, it was 1 million per year in a matter of hours. This was a saving per minute measured by the cloud provider. So yeah, that happens. I think in the future, maybe we need to think something else. But currently, it is also the way to start addressing the market. Make everything simple and let them trust your technology.
So what's your experience if a normal customer, so if I would use it or whoever, and what is the normal kind of optimization potential you see with Akamas that you can really get out of the stack? Is there kind of a rule of thumb? I would say 80% is probably a lot, right? But is it more like 20% or?
I think it's very complex. And there's a super nice question, of course, but it's very complex because we have customers, giants in the United States, that says us, I think if you are able to save me 1-2% is a tremendous result, because we spend months or years manually fine-tuning the code, fine-tuning everything, but we serve a million of customers, so just a 1%. And Aka was able to say something like, is a 13% improvement in performance that they calculate the amount of millions. So 13, you say, oh, it's not so good. But it's a giant that say, we usually get something that is less than 1%. On the other side, we have customers that create an old style, so lift and shift approach with the clouds, and they do not really they created their own EC2 instances with a rule of thumb, really. So Akamas was able to, because I really trust the infrastructure as a code approach, Akamas can also consider parameters, the size of a EC2 instance, the family of the EC2 instance, the number of EC2 instance. So Akamas, we include this kind of parameters. Akamas was able to change the way the architecture was created. So instead of having 3 big machines for the databases, 4 medium, X, 8, something for the other, change totally also the balance between the front end, the back end, the middle. We're changing the family of the type of EC2 instance. It was able to save like 91% of the cloud cost. 91%. Just changing the family, the number, and the size of the machine without touching really the front-end level parameters. Then when we add also this layer at the real full stack, the improvement was greater. But it was just a matter of the customer that was not aware about which is the best one. So somehow reading some forum that for databases, this kind of machine is good. So if you address customers that are, starting with the cloud native journey, sometimes the results are dramatically. If you deal with very, very mature customer, sometimes it's a matter of 10%, 20%, but they are so big that the results is tremendous anyway. So that's cool.
I mean, even 10% is really good, right? If you basically don't have to do a lot, right? It's the AI and the tool does the optimization for you. And as far as I understood, the risk for doing something bad is very, very low, right? It's almost
very
zero,
low.
you said?
It's very low.
Yeah.
So we combine 2 different approach. If you don't want to work directly in production, we can use pre-production environment or clone, because our AI is able to drive stress testing. So we don't want to invent yet another stress testing tool. So we start in this way, avoiding to because, if you start, we started in 2017. If you start telling to a customer that we change things in production, they never trust us. So at the end, we started to say, okay, pre-production, we integrate with your load testing tool that you already have in place, Load Runner, JMeter, K6, NeoLoad, whatever you have. So we integrate with also this kind of tool. We continuously integrate with your observability tools. That's interesting because we force the customer to install observability tools also in pre-production environment. So that's also why observability company love us, because we force the customer to improve their assets at the end, because cover full coverage also of the pre-production environment. That's something that is not so usual, especially for a matter of cost. But that's cool because now we have a full coverage of the pre-production environment. As soon as Akamas find the best configuration, we can move to production. So that's the first way to be very safe. If we work directly in production, Akamas works in a slower way, so it's not so aggressive. That's also parameters that you can set about the aggressivity of the changes. So if your Akamas immediately understand that you are over-provisioning the memory and they can cut by half the memory, in production, usually what they say, hey, start reducing the memory by 2-3%. Everything is good? Yeah. So move and move and move step by step. Of course, it's slower. Maybe it's not a matter of hours. It's a matter of a week. But you are working in production. You have the guarantee that everything is safe and you get tremendous results without having all the process to clone the environment and work in pre-production. So we usually ask to the customer, it's up to you. The license is exactly the same. So an optimization working in pre-production or running in production consume the same amount of license, so no issue about that. And then we have customers that mix the approach. So for very critical application, prefer to use Akamas in pre-production and then move to production and reuse what Akamas learned in pre-production. So then the AI is already a little bit trained. So it's another matter of having the guarantee that you do not crash anything.
No, makes sense. I just listened to an interesting podcast about Cursor AI. I don't know if you heard about it. There's this AI code editor where it suggests you code that you should write, but it also optimizes things. And they have the idea of doing shadow repositories. So basically, they clone the file system, and then an AI agent will actually, maybe through the night, work on your code, test things out, because it's just a clone. And if it works or if it's better, then they will tell you the next morning, look here, I found a bug and I optimized this code. I refactored this. I found that idea pretty interesting. And as far as I understand, this is similar here. You take a non-product environment to do these changes. And then once it works in the load test environment, in your kind of shadow environment, then you can apply those changes to production.
Yeah, it was exactly the same approach. So I know there are a lot of interesting, similar, complementary approach to the Akamas one that is on code. I think is a total different story. Over there, I think that Gen AI can help a lot. We totally are pretty 100% sure that Gen AI cannot help in our specific domain. It was funny because in one of the when Bert, the Dynatrace CTO, introduced the different AI working in Dynatrace, said exactly the same things. I love that because it says for specific topic in the operation, in the ops area, there are some area where the Gen AI cannot deal with. One is optimization. It was perfect because it's exactly what we are claiming. So he say that a Dynatrace is composed by several different AI that address different area of the operations, and I agree. For the optimization part, every single customer is totally different. Every single application of every single customer is totally different. So you cannot reuse the same training. So you can't reuse what an AI learned. That's why we need to learn instantly. So exactly on the fly. And that's also Akamas is very small in terms of footprint, because not training a model, no, it's just a set of microservices that work very close to your environment, connect to your environment. So it can be deployed on Kubernetes as a matter of pods. So
you can be deployed on-premise, or is it a cloud service, or both?
Currently, it's only on-prem. Why? Because customers are too scared to have an AI in cloud that can change things in your production system. So we decided to move directly to start on-prem and say, as soon as the market is pushing us to move on SaaS, we are ready to do that. But we don't want to, we are a small team currently because we are less than 20 guys. So I don't want to waste time currently if there's no need from the market to be on SaaS. And to be honest, currently it works because one of the first questions that I got from the customer is that, hey, come on, you can't be on cloud. I say, no, we are not on cloud. We can't be. We only be on-prem, so it's up to you. If you want to install it in your cloud environment, it's fine for you, but it's It's on your Kubernetes or your EC2 instance that is on cloud, but it's not up to us to offer a SaaS service currently. Maybe in the future things will change, but
yeah, I can see that. And it's probably also that your customers is more larger enterprises at the moment, right? Who have larger data centers and applications.
Maybe we are addressing large enterprise. Why? Because they feel the pain or they already tried other tools that only... Why I always... the full stack mantra we have. Because there are other tools that work in this way. I love them. Turbo itself, for some reason, is similar to Akamas, but what are the big difference with all this kind of tool and the unique of Akamas? That we really use in our AI all metrics at the full stack level. So we need all metrics. That's also, a showstopper sometimes if a customer really know they only have system metrics. So their observability tools is just old style observability tool. They only import CPU, RAM, usage, and so on. They have no end user metrics or high-level Java, virtual machine metrics, and so on. Akamas usually can't work. So we suggest customer, before moving that, ask to a consultant company to improve your observability approach. Otherwise, Akamas is blind. So it will work maybe, but there are some also other open source tools that can give you exactly the same. So a little bit of recommendation based on the fact that it considers CPU and memory. But it's very risky. Because if you only consider memory and CPU and you do not look at the end-user response time, the errors, or some high-level metrics, you can create a mess in your system. So that's the full stack mantra. And also that's why I love the hotel approach. Because the promise of a hotel is that every single technology itself will expose their internal metrics in a standard way. That's exactly the dream of Akamas, having all the technology, all the pieces of the puzzle, that without having an agent that grab data from them, but the technology itself with the exposed data in a standard way, it's the best way for Akamas to have everything in one unique place, in the same standards, without creating parsers and so on.
So we both root for open telemetry. So Luca, thank you a lot. This is one of the stories I really love. It's a European story, which I like. It's technology, AI technology out of Italy. And it sounds so amazing, the story that you have shared, that I will definitely try it, right? I want to see how it works. It sounds so amazing that you sometimes can't believe it, right? That it's working out of the box, right? Yeah.
So that's the feedback that we got from customers. Say, it's a dream, so it can be possible. So say, okay, try that. You need to be very mature in automation. You need to be very mature in observability. But if you are mature enough to have this kind of tools already in process, already in place, Akamas can be installed in a snap and give you results in a matter of hours. So it's just a matter of try that.
Yeah, thanks, Luca. It was nice having you here. Thanks for joining us on the podcast.
Thank you. Ciao. Have a nice day. Bye.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by Zero. We make observability easy for every developer.